So now we are ready to discuss the different kinds of constructors which we can have in an object-oriented programming, object-oriented program. So the first one is default constructor. We also have parameterized constructor. We have seen parameterized constructors in the previous programs. Apart from this, we have a copy constructor and we also have a dynamic constructor. Okay, so these are the four kinds of constructors which we can have in our programs. So the first one is the default constructor. So it's convenient to be able to give variables of type distance a value when they are first created. So you might remember that we created a class distance, and this class contained two private members, int feet and double inches, right? And it had some public member functions, for example set data and display data. It also had a member function add distance, which could add the distances of two objects. Okay, so what are we trying to say here is that if we are able to give the variables of type distance, what do we mean by variables of type distance? Type distance means class distance. Here we have created a class distance, but we can also treat this class as a new data type because we are able to perform operations on the distances given in feet and inches. So we are in a way creating a new data type. Okay, so class is a new data type which is a user defined data type, and the variables of this data type is the objects d1, d2. These are the variables. Okay, so it is convenient if we can assign them values when they are first created. Okay, so here we are creating them, and we have already seen this. We want to initialize them when they are first created. So it becomes easy for us to initialize them when they are first created. Okay, so in that case we do not need set data, we can create a constructor. Okay, so that is, we would like to use the definitions like distance, width 5, 6.25. So what is distance here? Distance is the type or the class. Okay, and width is the variable, or we can say the object, and we are initializing this. So we are passing two values. So first value will be assigned to feet and the second value will be assigned to inches. Okay, so we would like to use this format. Okay, this format. So if we want to write the statements like this, then what we have to do? We have to create a constructor. This you already know. So for this we do not need set data anymore, but we need a constructor. So the name of the constructor is same as the name of the class, and here let us create some formal parameters. Int f comma double inches, f equal to feet, and feet equal to f, and inches is equal to in. Okay, so this constructor is called automatically when we create an object, and the values which we pass are automatically assigned to the data members of this class. Okay, so to do this we write a constructor like this: distance int feet float inches. So this is another form of initialization, which is the preferred form of initialization. So here ft is equal to feet, feet is equal to ft, and inch is equal to in. Okay, so we want to use this type of assignment, this type of initialization when we create the objects, and for this we need to create such a type of constructor. Okay. However, we also want to define variables of type distance without initializing them. We also want to do this. Okay. We also want to do this. So here what are we doing? We are creating the variables, that is the objects of type distance, but we are not initializing them. D1 comma D2, these are uninitialized. Okay, like this. Okay, so let me erase this content. Even if there is no constructor in a program, but still object definitions work just fine. So in the previous programs, you saw that we created, in the very beginning, we created no constructor. Okay, instead of constructor, we used a function set data. Okay, and when we created the objects, we wrote distance d1 comma d2. So there were no constructor, but still we were able to create objects d1 and d2. So now the question arises, how could they work without a constructor? How were we able to create these objects without a constructor? Because an implicit no argument constructor is built into the program automatically by the compiler. And it is this constructor that created the objects, even though we did not define it in the class. Okay, so there is a default constructor. Default constructor, which is no argument constructor. It takes no arguments, which is created implicitly. Okay, if we do not create our constructor, the compiler creates it, and the compiler creates a no argument constructor. Okay, like this. This is a no argument constructor. And when the compiler creates this no argument constructor, through this no argument constructor, we are able to create the objects like this d1 and d2. Okay. And this no argument constructor is called the default constructor. If it weren't created automatically by the constructor, you would not be able to create objects, because the objects are created only through the constructor. Constructor is compulsory to create an object. So if you do not create your own constructor, then the compiler will create it. Okay. So if there were no constructor, then you would not be able to create any objects. Okay, for the class in which you created no constructor. Okay, but if you created on your own constructor, what will happen then? In that case, compiler will not create its own default constructor. Okay, so for example, you created your own constructor. Okay, suppose distance. Then in this case, when you are creating objects d1, d2, then the compiler will not create its own constructor, rather it will use the constructor created by you. Okay, only if you do not create any constructor, in that case only the compiler will create its own no argument, that is the default constructor. Often we want to initialize data members in the default constructor as well. Okay, sometimes we just create the default constructor like this, we do nothing in it, but sometimes we can initialize data members in the default constructor also. So if we let the default constructor do it, we do not really know what values the data members be given. So what happens? If you do not create your own default constructor, the compiler will create it. And when the compiler creates a default constructor, then it will initialize the objects. It will create the data members, inches and feet. Okay. Let me explain it more clearly. Okay. So suppose you created a class distance. Here you have int feet and double inches. Okay, and in the public section you are not creating your own default constructor, rather you have a set data function to set the data. Int f double I, and here feet is equal to f and inches equal to I. And okay, suppose this is the class, and here we have the main function, and you write distance d. Okay, so what are you doing? You are creating an object. An object will be created only through the constructor, but in this program you have no constructor. Then what will happen? The compiler will create its own constructor. Okay, and that constructor will look like, okay, so this is the constructor the compiler will use. And what will happen when this statement is executed? Memory will be allocated for object D, and D contains two data members, feet and inches. So memory for feet and inches will be allocated. Okay, but when we do not put the values inside a variable, then what value do they contain? They contain a garbage value. Similarly, in object D, feet and inches will contain some garbage value. Okay, so they will contain some garbage value. So if we let the default constructor initialize the objects, we do not know what values the data members may be given. They can be given any garbage value. But if we care that what values they may be given, we need to explicitly define the constructor. So if we do not want these garbage values, we want some initial values, specific initial values to be given to these feet and inches, these data members, then we must create our own default constructor. Then how to create our own default constructor? Default constructor means it contains no arguments. Okay, so it will look like the function declarator will look like this. Okay, and inside this we write feet equal to, suppose we want to initialize it to value 0, and inches is equal to 0.0. Okay, so now instead of let us add this default constructor here in the class. Okay, now when you create an object of type distance, that is when you execute this statement, D will be created through which constructor? Now the compiler will not create its own constructor, but it will use the default constructor created by you. Okay, so when you define your own default constructor, the compiler will not create his default constructor. Okay, so this will be used and object will be created, but this time the initial values will be the values which we defined here. Okay, hello, hello. So here is the same example. We have the class distance. Here we are defining the constructor outside the class. Okay, so when you want to define the, it is in, so here is the same example. this constructor distance contains initializes two data members, feet to 0 and inches to 0.0. Okay. So this is an example of the default constructor. Now we can use the objects initialized by no argument constructor and be confident that they represent no distance. So no distance means they are always initialized to 0 feet and 0.0 inches rather than some arbitrary value. If there are two explicit constructors with the same name, then we can say that constructor is overloaded. So in the program in which we introduced the constructors, we used multiple constructors. I think one of them was the default constructor, in which we initialized feet and inches to 0 respectively, 0 and 0.00 respectively. And there was another constructor which is called the parameterized constructor. Parameterized constructor is similar to the default constructor, but the difference is that it takes arguments. So if the constructor looks like this, then this is called the parameterized constructor. Okay. So here the values will be passed when we create the object. So feet is equal to f and inches is equal to I. Okay. So when you create the object, distance d, if you pass the parameters, if you pass the arguments, then instead of the default constructor, this constructor will be called. Okay, because here we have two arguments. So the matching constructor will be called, and these arguments will be copied in these formal parameters int f and I, which will then be used to initialize the feet and inches data members of the class distance. Okay. So when you have two constructors of the same name, two or more constructors of the same name, but their parameter list is different, then we say that the constructors are overloaded. So here what are we doing? We are creating a class of type distance. We are creating an object of type distance whose name is length. Now we have no arguments here. Then which constructor will be called? The default constructor will be called. Okay, and next you are creating another object width of class distance, but here you are passing two arguments. So which constructor will be called? The parameterized constructor will be called, as we have seen in the programming exercise.